Hi students, 3.2 graphing f of x is equal to ax squared plus c. So when you wrote down your 3.1 notes, we just had ax squared. Now we're introducing you to c, okay? Remember c, c is the y-intercept. So when we're going to graph this, because it's going to ask us to graph it, or it might just say what is the y-intercept based off the function. Whatever that number is, that's your y-intercept, okay? So if that number is greater than 0, so if you have something like x squared plus 5, and we know that it's greater than 0, then we call that a vertical shift 5 units up, okay? So because of this 5, we have a vertical shift. A lot of students like to use shift. It's the same thing as translation, where we're moving it. A vertical translation, you can use that word as well. It's a vertical shift or vertical translation 5 units up. So I'm going to write that out. Vertical shift up 5 units. Okay. Now, if c is less than 0, so let's say you have something like y equals x squared minus 2. So if it's less than 0, again, we have a vertical shift or translation 2 units down. So this tells us where it's moving up and down on the graph. So vertical shift down 2 units. Again, you can use shift or translation. Okay. Okay, so let's talk about example 1. We are going to graph g of x equals x squared minus 2. Compare it to f of x equals x squared. Now, a is 1. Okay, so it's not, there's no negative, so we know that it's going to be opening up. The graph should be opening up. And because of this minus 2, we know that there's going to be a vertical shift. Remember, up and down, and it's going to go down 2 units. Doesn't mean it's opening down. It's still opening up, but it's going to, that vertex is going to drop down to -2 on your y-axis. Okay, and that's what we're doing. Remember, f of x, we can use this highlighter, and remember the coordinates of f of x from 3.1. We said to use -1, 0, and +1. You end up 1, 0, 1. You can graph that. Okay, so that's gonna look like this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So this is your x, this is your y value. I'm going to go ahead and graph the parent function now. And my points are going to be 0, 0, -1, 1, 1, 1. Okay, it's always good. You can keep going if you like, but we know this is the general graph. This is f of x. Okay. Again, we know this is going to be opening up, but its vertex is going to be at a -2. It's going to be dropped down 2 units. So what does that look like? It looks like this. We're going to use -1, 0, and +1. I'm going to use pink to graph this. So we're going to take that -1 and we're going to plug it in here. -1 squared minus 2. -1 squared is +1. 1 minus 2, that gives you -1. Okay, so negative 1, whoops, not negative 1, 0 squared minus 2, negative 2. Okay, and again, I'm just putting this in. 1 squared is 1, 1 minus 2 is negative 1. Okay, let's go ahead and graph. Again, this is going to be my pink graph, so it's going to be negative 1, negative 1 here and here. Okay. And there you have it. This is f of x. This is g of x. Okay, so let's talk about this. Both graphs are opening up. The AOS, the axis of symmetry, is going to be the same. Okay, AOS is x equals 0. It's the same. The vertex of, oh, check this out. Vertex of f of x. So the yellow graph is 0, 0. However, the vertex of the pink graph, which is g of x, so if it's asked you to compare or identify the whatever, in this case we're comparing, okay, g of x is actually 0, comma, negative 2. And again, g of x has a vertical shift 2 units down. So from 0, 0. Okay. There you have it. All right, let's do one more and then we'll call it a day. Whoops. Graph g of x equals 4x squared plus 1. Compare it to f of x equals x squared. Remember, students, that 4, if a is greater than 1, 0, I mean 1, then we know that, well, you know what? I forgot. Whoops. If you forgot, go back to your notes. I really didn't forget, but I want to show you something, okay? Say if you did forget. This is why we take notes. Let me go check and see what we wrote down. 3.1. If a is greater than 1, it's 4. Then we're going to have a vertical stretch, which means it's going to be thinner. We're going to have a vertical stretch by a factor of 4, which means it's going to be thinner than f of x, than our parent function. Okay, so vertical stretch by a factor of 4. We also had a plus 1. That means that plus 1, that's what we learned today. Of vertical shift up 1 unit. Okay, so it's going to be a vertical shift up 1 unit. So it's going to be thin, but up 1 unit from the parent function. So if this is the parent function, it's going to be thin and it's thinner. Okay, and then it's going to be up 1. So that's what we want to make sure our graph looks like. If it doesn't, then we know we did something wrong. Okay, all right. Quickly, negative 1, 0, 1. That means we have 1, 0, 1. That never changes. Remember, never changes. Okay, this pink, we can use negative 1, 0, and 1. We'll graph that in just a moment. I want to go ahead and plot my points now. Let's go. It's going to be in the first and second quadrant, so we can do this. 1, 2, 3, 4, 5. We'll go out 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. 0, 0, -1, 1, +1. You should have that memorized. F of x. All right, so now we're trying to figure out what does g of x look like. So we're going to take this -1, we're going to plug it in here. 4 times a -1 squared plus 1. -1 squared is 1. 4 times 1 is 1. Plus 1, that gives you 5. 4 times 0 squared plus 1. 0 squared is 0. 0 times 4 is 0. 0 plus 1, 1. 4 times 1 squared plus 1. 1 squared is 1. 4 times 1 is 4. Plus 1 is 5. So let's go and graph this. -1, +5. -1 up 5. There it is. We have 0, 1. So up 1. 1, 5. Again, if you have graph paper, that will make it look so much better. Again, we're going this way. Arrows, okay? This is g of x. Pink. It's g of x. Okay, a couple of things. We said g of x is thinner. G of x is thinner than f of x, than our parent function. What else do we know? Vertical, there's a vertical stretch. What's making it thinner? It's that 4. So we have a vertical stretch by a factor of 4. Okay, what else? G of x is going up 1 unit, so there's a vertical shift up 1 unit. Okay. Let's talk about the vertex. The vertex of f of x, 0, 0. The vertex of g of x is actually 0, 1. And the AOS is still going to be the same. We haven't shifted left or right. Okay, it's just up and down. So that vertex is, both of them are in 0. So if we draw, I'll take a green marker. Notice how it'll cut the parabolas into 2 equal parts. So let's go and write that out. We can say same AOS, which is x equals 0. Woo! That's a lot, but you can do it. There it is. All right, have a good day.